Let us consider this problem of solving a LPP using a graph, okay, with graphical method. Let us consider the first constraint as an equation. The first constraint is considered as an equation x1 plus 2x2 equal to 40. When you put x1 is equal to 0, this term will go off and you will be left out with 2x2 equal to 40, which implies x2 equal to 40 by 220. When you put x2 equal to 0, this term will go off and you will be left out with x1 equal to 40. So, the points are x1, x2, 0, 20 and 40, 0. Now consider the second constraint as an equation 2x1 plus x2 equal to 40. If you put x1 equal to 0, this term will go off. You will have x2 equal to 40. And if you put x2 equal to 0, this will go and you will have 2x1 equal to 40, which implies x1 equal to 20, 40 by 220. Now let us consider the third constraint as an equation x1 plus x2 equal to 60. When you put x1 equal to 0, you get x2 equal to 60, and when you put x2 equal to 0, you get x1 is equal to 60. So the points are x1, x2, 0, 60 and x1, x2, 60, 0. Okay, fine. Now, seeing all these points, the maximum value to be plotted is 60 and the minimum value is 0. So I select a scale in such a way that all these points can be accommodated. Okay. Fine. Now the points are, let us consider the first constraint. The points are 0, 20 and 40, 0, right? 40, 0. So let us join these 2 points by means of a straight line. What is the equation? The first equation, x1 plus 2x2 is equal to 40. See, this line divides your graph into 2 parts, one part above the line and one part below the line. Which is your part? To consider it, take a testing point. Let us take origin as the testing point so that the calculations become easier. Put x1 equal to 0 and x2 equal to 0. You get the answer as 0. The inequality says the answer that you get in the left should be greater than 40, but you are getting a number less than 40. So you say that this is not your region. The region which has origin is not your region. It is not satisfying the condition. So this is your region. The region to the opposite of this is the region. Okay. Now the second constraint, the points are, we didn't write the points. The points are 0, 40 and 20, 0, right? 0, 40 and 20, 0. Okay. After drawing a line, don't forget to write the equation on the line 2x1 plus x2 equal to 40. Again, take origin as the testing point. Go to the second constraint in the problem. put 0 for x1 and 0 for x2, you get the answer as 0. And the question says your answer should be greater than 40. No, the answer you're getting is less than 40. This condition is not satisfied. So put an arrow in the opposite direction. Okay. Now coming to the third constraint, the points are 0, 60 and 60, 0. Join these 2 points by means of a straight line. Right? Write the equation upon the line x1 plus x2 equal to 60. Take origin as the testing point. Go to the question. Put x1 equal to 0, x2 equal to 0. You get the answer as 0 here. And the question says your answer should be less than 60. Yes, the 0 is less than 60. So put an arrow facing the origin. The condition is satisfied. Now your region is above these 2 lines and below this line, and as usual it should be in the first quadrant. Okay, so this is your area. Now let us name the corners A. Let me call this as B, and let this be C and this be D. So A, B, C, D is the feasible region. A region which satisfies all the constraints of the problem is called a feasible region. Okay. What is your A? A can be calculated as located at site. It is 0, 60. What is your B? It is 0, 40. Right? Okay. Now, see your C lies, what is your C? You have one more corner, right? A, B, C, D. This is your E. Okay, A, B, C, D, E. Right. Your C is 40, 0. And your D is 60, 0. What is your E? Your E lies on this line and this line. Right? So to find E, see, we have 2 unknowns. This is one line, right? The coefficient of x1 is 1, x2 is 2, and the term on the right is 40. Your A2 is 2, B2 is 1, C2 is 40. So you're getting the answer for x is 13.33, right, comma, y is again 13.33, right? So 13.33, comma 13.33, right? Now let us calculate the value of z at all these points. Z is equal to, the question says it is 10x1 plus 6x2. 10 into 0 plus 6 into 60, right? It is 360. Z is equal to 10 into 0 plus 6 into 40. It is 240. Z is 10 into 40 plus 6 into 0. It is 400. 10 into 60 plus 6 into 0. You get 600. Z is equal to 10 into 13.33 plus 6 into 13.33. Into 13.33 plus 6 into 13.33, you get 213.28, right? Now see the question. You want the minimum value, right? You want the minimum value. Which is minimum among all these? This is minimum. So your answer is the optimum solution is the solution which is the best solution. The optimum solution is x is equal to x1 is equal to 13.33, x2 is equal to 13.33, and minimum value of z is 213.28. Okay, this is the final answer, right? And finish this by writing the scale you have taken